The third law of vector addition is called Polygon Law of Vector Addition. Alright. So what Polygon Law of Vector Addition, this law is for n number of vectors. For example, we have more than 2 vectors. For 2 vectors we already have 2 laws, triangle law and parallelogram law, and in a way it is actually one law, right? Same formula, same type of derivation, same. Polygon law deals with when there are n vectors acting at some place. For example, consider these vectors: vector A, vector B, vector C, vector D, vector E. These are 5 different vectors which are acting at different points. But if I have to add all these vectors, what I can do is, according to this law, if n vectors are to be added, then they can be taken as n consecutive sides of a regular or irregular polygon. So just remove this word irregular, regular. If n vectors to be added are taken as n consecutive sides of a polygon, then the resultant would be the last side of polygon taken in opposite order. So the statement is like this: if n vectors to be added are taken as n consecutive sides of a polygon taken in same order, then the resultant would be the last side of polygon taken in opposite order. So how do I make the diagram for the polygon law? I will be taking the vector A first. Suppose this is vector A. Then I am taking vector C. Okay, vector C is like this. Then I am taking vector, I have taken A, C, I am taking vector D. Vector D is in this direction. Then I am going for vector B. This is vector B. And lastly, I am taking vector E. This is vector E, right? So what I have done, I have taken those 5 vectors as n or 5 consecutive sides of a polygon taken in same order, then the resultant would be the last side of polygon taken in opposite order. The same order would have been like the arrow would have been here, but I have to take the last side in the opposite order, so this is the resultant. So this means that this R will be producing same effect what vector A, C, D, B and E will be together producing. So this R can be written as vector A plus vector B plus vector C plus vector D plus vector E. And the proof of this is very simple. See, if we can apply triangle law in vector A and C, I will be getting this vector according to triangle law. This would be vector A plus vector C, right? Then the work of these two has been done, so I can actually remove them because resultant has already been figured out. The resultant of this vector and this vector would be according to triangle law this vector. So this vector will become vector A plus vector C plus vector D. Again, resultant of this vector and this vector will be this one according to triangle law. So this will become this whole plus vector B, and lastly the resultant of this plus this, what was added here, plus vector B was added, so lastly this plus this will give you this whole plus E, which is this. So this is how Polygon law of vector takes place. It simply states n number of vectors can be simply added by taking them as n consecutive sides of a polygon, and they are taken in same order. Finally the resultant is taken to be the last side of polygon taken in opposite order. One very important point here is that if we have more than 10 or 20 vectors, if the value of n is very large, the resultant will always be equal to 0, because in that case the sides, if I will be taking, just a second, if I will be taking n sides like this, if I keep on taking n number of vectors and the number of vectors is very large, so somewhere the chain will be completed, the whole cycle will be completed, so you won't be left with anything in the last. Okay, so that is why this, if the value of n is very large, then according to Polygon law the resultant is always 0, but otherwise we can do in bits and parts by applying triangle or parallelogram law.